Bismillahirrahmanirrahim. Welcome to the presentation on Packet Tracer Lab on Etherchannel. So in this lab demonstration, I will show how to configure the Etherchannel using PAGP protocol. Before we step into the configuration part, you have to understand what is the necessity, what is the need for Etherchannel. Now this is switch 2 and this one is switch 3. So between the two switches, the switch at the top is switch 2 and the switch at the bottom is the switch 3. You can see there are two links. Since there are two links, there is a possibility for looping to occur. To to prevent the looping, the switches by default they enable the spanning tree protocol. The spanning tree protocol is already invoked and it would block a certain interface between the two switches. So you can see here the orange color. So here this interface with the switch 3, the bottom switch, okay, this particular interface is blocked. FA02 is blocked. So you can go and check here. Okay, go to the switch, then enable show spanning tree, and you can see FA0/2 is blocked, BLK, blocking state. So the cost of this link is 19. It implies that the speed is 100 MB per second. So each link, okay, 100 MB per second. So we have two links here, each 100 MB per second. However, one link cannot be utilized because it is blocked by the spanning tree protocol. So to avoid the looping problem, the spanning tree protocol is blocking, okay, one link. So we are wasting 100 MB per second. If this particular interface is not blocked, we would have got 200 MB per second. So we have to compromise 100 MB per second bandwidth. So what is the solution? We want to overcome this problem. The solution to this problem is called Etherchannel. When we implement the Etherchannel, what it would do, it would make these two individual links, it will group these two individual links into a single logical entity called channel, port channel. So it will combine these two links, two or more links, into a single logical link. In Cisco, up to 8 links between switches can be combined into a single link, logical link. Okay, that is called channel. And the switches in Cisco, they support up to 6 channels. To implement the Ether channel, there are protocols like PAGP and one more protocol that is called LACP. So these are some of the protocols which are available to implement the Ether channel. However, today we are going to discuss about the PAGP. So now this topology, we have 4 machines Okay, two machines at the bottom connected to the switch 3 and two machines at the top connected to the switch 2. This FA0/1 in this switch and at the top switch they are in VLAN 10, and FA0/18 at the bottom switch as well as at the top switch they are in the VLAN 20. This is just to make you understand that this is a trunk link. It carries multiple VLAN traffic. Okay, so the exact problem is the spanning tree protocol is blocking one link to avoid the looping. So only one link is active. So we are getting only 100 MB per second. So the bandwidth is getting wasted. So to avoid that issue, the Ether channel can be configured which would combine these links into a single logical link. So first let us go to this switch. Let us check whether we have VLAN or not. However, the VLAN is not needed for this Ether channel configuration, but since we have some PCs connected to the switch, they are in VLAN 10 and VLAN 20. So let us revise the VLAN concept also in this lab. So let us configure the VLAN 10 and VLAN 20. So we have created two VLANs in the switch 2. I mean switch 3. This is switch 2. So I go here, enable config key, no IP domain lookup. Okay, we don't want this domain lookup to happen and waste our time. So I'm giving this command. So I'm creating VLAN 10, then I'm creating VLAN 20. So two VLANs has been created. Now let me go to this. FA0/1 is in VLAN 10 and FA0/18 is in VLAN 20. So I want to configure that. Exit. So interface FA0/11. Okay. Switch port mode access. Switch port access VLAN 10. Exit. Then I go to interface FA0/18. Switch port mode access. Switch port access VLAN 20. Okay. So these two interfaces FA0/1 and FA0/18 has been put in access mode, and FA0/1 has been configured to VLAN 10 and FA0/18 has been configured to VLAN 20. Now there are two interfaces here. They are FA0/1 and FA0/2. They are trunk. Okay, so we have to put them these physical interfaces in trunk before we configure the channel. Okay, so let us do that. Exit interface range FA0/1 until 2. Okay, switch port mode trunk. So I'm just putting these two interfaces as trunk, and then after that let me go to switch 2. So here already we created the VLAN, so let us put the PCs in respective VLANs. So interface FA0/1. Okay, so FA0/1 belongs to FA0/1 belongs to VLAN 10. Okay, so there is a mistake I have done, so I will fix it. So it should be 1.11. Okay, and this should be 2.11. Okay, so I think this is FA0/1, this one. Okay, so I go here. So I go to FA0/1. Switch port mode access. Switch port access VLAN 10. Then I go to interface FA0/18. Switch port mode access. Switch port access VLAN 20. Then we have two interfaces here. They are in trunk. They are FA0/1 and FA0/2. So we have to put them in trunk. So interface range FA0/1 to 2. Okay, switch port mode trunk. So please remember, before we configure the Ether channel, the physical interfaces which connect the switches should be put in trunk mode. This is very important. Okay, suppose these interfaces are access, and if these two interfaces are trunk, then we cannot create the channel. Suppose suppose these interfaces are fast Ethernet and this one is giga, then we cannot create the channel. Suppose these interfaces speed are 100. Okay, this one is giga, it is speed is 1000, we cannot create the channel. So the settings, okay, of these interfaces should be same. Okay, and suppose these interfaces, they are in trunk and they allow the VLAN 10, VLAN 20. These interfaces are in trunk, they allow VLAN 10 only, then also the channel creation cannot happen. Okay, so exit now. So we are going to create the channel. So where are we now? We are here. Okay, we are in the switch 2. So host name switch 2. We are in switch 2. So we are now going to create the channel. The command is interface FA0/1 until 2. So we have to go into the trunk interfaces. We have to go into the trunk interfaces. Okay, then channel group mode channel group 1. So we have to give a group number that would identify the channel which is created between these two switches. So the number starts from 1 and it can go up to like something like 200 values. Okay, so exact value you can refer to the CISCO manual. Okay, so channel group and the number you have to specify, and each channel what you create should be unique. It should have a unique number. Okay, the channel group number between different channels should be distinct. Okay, then we have to use something called mode. Already I have given in the class. Okay, the different um, so the different modes are desirable. Okay, so you can have desirable mode in one switch and in another switch also desirable mode. Okay, then channel will be created. In one switch you can have desirable, and in another switch you can have auto, and then also channel will be created. Okay, so in both the switches, if you give the auto mode, then the channel, okay, channel, it will not be created. So this is for PAGP. Okay, already I told in the class, desirable means if you configure a particular switch channel mode as desirable, then that switch would initiate the channel creation request. That would initiate the request to create the channel. And if you configure the other switch channel mode as auto, then whenever any request comes it will accept, but it will not initiate the channel creation process. So that is the difference. So in LACP, PAGP is Cisco proprietary protocol. This one is open source, which can be used in other. LACP is open source, can be used in other switches also from other vendors like Juniper, etc. So here, instead of desirable, we use the command active. Instead of uh, here, here also same, just command is different, but same functionality. So active. Instead of auto, the command used is passive. Okay, and passive, passive, it won't create the channel. Okay, so in LACP, you have to use the active and passive commands. In PAGP, you have to use the desirable and auto commands. So this is the combination. In one switch, if you are using desirable, in the other switch, if you can use desirable also, then the channel will be created. In one switch you are using desirable, then other switch auto, then also channel would be created. But if in both the switches if you are using auto, then channel will not be created. And similarly, when you are going for LACP, okay, active channel will be created. Okay, then active passive channel will be created, but passive channel will not be created. Okay, so now we come back again to the configuration. So where are we now? We are in the switch 2. So in the switch 2, okay, we are here in the mode. So between the two switches in the switch 2, okay, I am going to give desirable. Why I am going desirable? Because the protocol we used is PAGP. Then what I do, I shut down the interfaces. Okay, this is the best practice to avoid any error during the channel creation as per the CISCO manual. So after I configure this, okay, I exit. Then I go to interface. We have created a channel. Okay, that channel has a number 1. So how to go into that interface? Interface port channel 1. Okay, then I say, so we have created here a port channel, and that channel has combined these two physical links, FA02 and FA0/1. Okay, now we have to put this end of the switch, I mean in the channel, this end into trunk mode. So now this is the logical interface what has been created. So I'm going to put in trunk mode. So switch port mode trunk. So already we did with the physical interface, okay, beginning. Now we are doing with the logical link, okay, which we refer as channel. Okay, so once you done this, what I am going to do, I'm going to switch 3 now. Enable, okay, config key, host name is 3. Okay, then just let me recall what we have done before. Yeah, we put all the interfaces in trunk, and also we configured the VLAN also. So now we are in the we are ready to create the channel. Okay, so interface FA interface range FA0/1 until 2. Okay, switch channel group, 1 mode. You can see the mode. So already I told you the mode, if you want the channel, either the second switch can be desirable mode or auto mode. Okay, whichever is okay. So I'm here, right? So I let me put auto. So in your lab manual, whatever lab exercise you are doing, you have to check what mode they prefer for the first switch and the second switch. So then I shut down the physical interfaces. Okay, then I exit. Then I go to the channel interface, port channel 1. Then I make that as uh, trunk mode, switch port mode trunk. So we are finishing this configuration. Okay, then okay, let me go to switch 2. Okay, I go to the physical interfaces, interface FA0/1 until 2, interface range FA0/1 until 2. Give no shutdown command. because we shut down before earlier. So now we open the interface. Then I go to switch 3 also. Interface range FA0/1 until 2. Okay, no shutdown. I open this interface. So now here both the logical interfaces are up. You can see the red has changed to orange, and now slowly the green would come. The spanning tree protocol is in the process of selecting the root bridge, and it is in the process of selecting the root port, designated port. Okay, and now you can see both the links are green. You can see there is no port is blocked. Why it is not blocked? Because now this both the links belong to a channel. They are from these two physical links, a logical link which we call as port channel with the number 1 has been created. So it is existing as a single link, and the spanning tree protocol also is existing, but it will not block the traffic. So let's go here and check show uh, show ether channel summary. I'm sorry. So you can see here this is the port channel number. Okay, and this port channel is created using PAGP protocol, and you can see it has two interfaces, FA0/1 and FA0/2. Okay, and you can go here, show ether channel summary. Okay, then also you can test show spanning tree protocol. You can see they are uh, they are existing as a single interface, PO. Okay, port channel 1. Okay, and from here, let's say I want to ping the VLAN. From here I want to ping this machine 2.1. Ping 192.168.1.11. So now it is pinging. Actually, the IP address what I gave inside the PC was wrong. So it should be 1.11. So FA0/1. Okay, you can see this FA0/1 in VLAN 10 in both the switches, and FA0/18 VLAN 20 in both the switches. And you see the VLAN 20, the network address is 2, and the VLAN 10, the network address is 1. And also from VLAN 10 we cannot ping VLAN 20 because we don't have the inter VLAN communication that we will discuss in the later topics. So that's all I have for this concept, ether channel concept. You can see yourself, both the links are active. We are getting 200 MB per second. Before We configure ether channel. There was only one link active, and another link was blocked by the spanning tree protocol. The spanning tree block protocol will not block the ether these links because now they are existing as a single logical link. Okay, thank you.